Okay, so for another type of problem, example number 3. When the blocks are released, determine their acceleration and the tension of the cable. Neglect the mass of the pulley. So this is kind of problem that we have a familiarization because of the topic kinematics of constrained motion. So you have to use kinematics principles as well as the kinetics principle. So first things first, as always, the given. So what are the givens? Of course, the masses. MA is 10 kilogram. MB is 30 kilogram. So for the required, the acceleration, their acceleration, AA, AB, and the tension of the cable. Since there's only one cable, there's only one tension. Solution. For the solution, I think we have to write the FBD outside the space diagram. Okay, so for MA, so the mass of A, for FBDA, we have, let's make it simple, T on both sides, and we have the weight of the cylinder A. So for FBDB, we have a simple cylinder, weight of the B, and one tension here at the top. So we're now ready to formulate the equation of motion. But first, let's try to analyze or assume where would be the direction of motion. Where would be the direction of motion? So first, here we have tension is equals to weight B, which is 30 kilogram. So if that is 30 kilogram, so this is 30, this is 30, 60, and WA is 10. So 60 is greater than 10. So the cylinder A would move upward for the VA, and of course VB consequently would move downward. Okay, is that a valid or a good assumption? Another consideration, let's assume that there is a hand holding this without the 30 kilogram cylinder B. The tension in the cable is equals to 5 kilogram because it would be divided by 2T, so 5 kilogram. So it takes 5 kilogram to hold the system. 5 kilogram to hold the system. So anything greater than 5 kilogram would mean motion, would mean acceleration. So 30 kilogram is much greater than 5 kilogram. So that is another analysis that would support this assumption, VA and VB. Okay, so for the equation of motion, first let's try with FA equals to on FBDA MAA. So since the motion is in this direction, the motion is in this direction. For A, that would mean 2T minus omega A is equals to MA AA. Alright, so for summation of forces along Y on object B, MB, AB, that would be WB minus tension equals to MB, AB. Alright, so this is equation 1, equation 2. Let's multiply this equation 2 by 2. That would be 2WB minus 2T 2MB AB, so that we can add equation 1 and 2, and the tension to T will cancel out. So the final is 2WB minus WA is equals to MA AA plus 2MB AB. Alright, so on the left side we have 2WB minus WA, these are givens. On the right side we have MA and MB also given. For AA and AB, these are not given because the question is the acceleration, one of the questions. So we have two unknowns, except if we can find a relationship between AA and AB, then it would result to one equation, one unknown. Okay, so for our next thing to do is to find the relationship between AA and AB, and we can do that from kinematic analysis of constrained motion. So if you can remember, the first step is to establish a datum line for each motion. Second is to create a position vector for each object. So this is SA, or it could also be here. It's just fine constantly. And for SB, okay. So the third step is to formulate a length equation. So the length of the rope, we have only one rope, so that would be 2SA, which is this and this, and SB, which is this, is equals to length. Next is to derive. We have 2VA is equals to negative VB. Another one, 2AA is equals to negative AB. Okay, so now we have a relationship between acceleration A and acceleration B, and that is 2AA is equals to negative AB. Okay, but be careful when you are connecting one equation to another equation, because the assumptions for this equation and this equation are very different, and when you try to carry this negative sign into this equation, it will mess up the whole process. It is because your assumption from the beginning, which is here, is quite different with the assumption compared to here. Here we make sure that this 2T is greater than WA, so that the positive sign of MAAA is kept. The same is true with this. We make sure that WB is greater than T from the FPD diagram, consistent with our assumption of motion for A and B, so that MBAB is also kept positive. Okay, so we have an expectation for AA and AB to be positive, because we have set that, we have made that way. So we cannot expect a negative acceleration of A and B using these equations. Okay, but here the assumption is quite different. Even though they have they have the same inertial frame of reference, but the origin of the formulation of this equation comes from the constancy of the length, and the corresponding interpretation of the negative for velocity and negative for the acceleration is only limited to the kinematic interpretation, and it should not be carried to kinetic interpretation. So here we need only the magnitude relationship of acceleration and AB, so that 2AA is equals to AB. This is all we need to connect this to this. We cannot afford to carry the negative sign, because it will make your process incorrect. Okay, be careful with this mistake. Remember that each equation has a set of assumptions, and their interpretation is limited only with those assumptions. They must not be interpreted beyond those assumptions, because that would be invalid. Okay, so to continue, we have 2 WB WA, because we are expecting a positive relationship on the left side and positive side, and if you introduce something else, it would really mess up the whole process. So MA AA plus 2 MB AB is 2 AA. Okay, we don't need the negative sign because this is from kinematic assumption and this is from kinetic assumption, and when you're trying to connect different dimensions, in order to have a common agreement, one observation must accept the other observation, or vice versa. So in this case, the 2AA or this equation abides with the assumption of this equation. That's why the negative sign is removed, because it contradicts with the assumption that we have already placed from kinematic analysis. I hope you get me. Okay, so continue. This is 2WB minus WA is equals to AA MA plus 4 MB. Okay, for MB. Okay, so we can solve now for acceleration of A, which is 2 WB is 30 kilogram, 30 G minus WA is 10 G is equals divided by MA, which is 10 kilogram plus 4 30 kilogram. So AA is equals to 2 times 30 times 9.81 minus 10 times 9.81 divided by 10 plus 4 times 30. 3.77. So 3.77 meter per second squared. Okay, so for AB, we have here the relationship AB is equals to twice of AA times 2, 7.55. Okay, they are both positive and we're neglecting the negative sign unless we need to interpret the effect of acceleration on the velocity of A and B. Okay, acceleration A 3.75, it means it is accelerating upward, and acceleration B 7.55, it means it is accelerating downward. Of course, the system has cylinder A and cylinder B will have different acceleration because of the way they are connected, unlike the previous example. Okay, so for the tension, I think I go this way, number 2. So WB, that is 30 G minus T is equals to 30 kilogram times AB, which is 7.55 meter per second squared. So the tension is equals to times 30 times 9.1 minus this is 67.92 Newton. So these are the answers. Acceleration A is 3.77 meter per second squared. Acceleration B is 7.55 meter per second squared, and the tension is 67.92 Newton.